Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So if we do our place value grid, and so we've got units here, tenths and hundredths. Don't think we need any more. So we can put in our number, it's 5.87, and you can see here that the 8 here is in the tenths column. So the 8 represents 8 tenths. If there were 39 people on the bus and 4 people got off the bus, that would leave 35 people remaining on the bus. So the fraction of people staying on the bus is 35 out of the 39 people on the bus. So our answer is, as a fraction, 35 over 39. We can't cancel that any further. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last 2 around to make sure that it is even. So our answer is 7,634. Mode means most common or most frequent, and looking at this list of numbers, the number that comes up the most is this 7. All the other numbers just come up once, a 7 comes up twice. Multiples are just a numbers times table, so to write the multiples of 11, we're just going to do 1 times 11, 2 times 11, 3 times 11, 4 times 11, and 5 times 11. Now we're not going to do any more because it says it just wants the first 5. So I'm just going to write those down in a list with commas, separating them. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10 including the back ones. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers costs £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in 2s, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be 1 high, because they're going up in 2s. And we need a way of showing male or female, so what I'm going to do is just shade the female there, and I'm going to just draw a key. I'm going to say if it's not shaded, it's males, and if it is shaded, it's females. Okay, next we're going to do the 8 and the 4. So what you can do is just do the whole thing, then split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And nice easy one to start off with is 10%. And we're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. And 1% we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20% we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240. We need to add the 50.4. Probably again don't need to show the working out for this. We can do this in our heads, but it's a bit easier to see what we're doing. So the answer would be 290.4. So to do this question, you just need a piece of paper, a ruler, and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on, will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here. And I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side. And I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total, and we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571 blah blah blah, and it says it wants it to the nearest percent, so that will be 29%. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit, and so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across. Let's try and get this just right. Line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. Whenever you have angles on parallel lines, you always draw out the letter in which they create. So we could have a situation here where the 2 angles create a Z like this, and those will be alternate. They could create a Z like this. That would also be alternate. They could create a C, which looks like that, and that would be interior, co-interior, or allied, depending on your preference. There could be a backward C. Again, that would be interior, co-interior, allied. Or they could look like an F. Now there are several Fs, about 4 Fs that they could look like. There's the F like this. There's the same thing but backwards. And there's the upside down versions. So you have the ones that go out this way. And the actual one we've got here, if I don't move that, the actual one we've got here which goes inward like that. Seem to be moving things. Let's try that again. So with all the F angles, we know that they're corresponding. Now, how do we figure that out? How do we remember that? There's loads of different ways. The way I remember it is I remember corresponding for corresponding. I remember alternate for alternate, and then either co-interior, interior, allied, I just remember as the other one. So interior, I just remember as the kind of C one, the other one. And so with this question, we've got x is equal to 73 because of F angles, and I just remember corresponding. So the word I write down isn't obviously corresponding, but corresponding. And it sounds silly, but I've remembered that for all my years teaching. I used to get corresponding and alternate mixed up. That was the way I remembered it, and I've never had an issue with corresponding alternate angles again. So whatever method you have, just to help you remember which one to pick, obviously have a method in advance of the exam, and then when this question comes up, you'll be more than happy to pick the right one. To work out the circumference, we need to first of all work out what the diameter of this is. And to do that, we just draw a line across the circle, and we can see the diameter is twice as big as the radius. So the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asked for, we just put the number first and then pi. So it will be 28 pi. A sample space diagram is basically a diagram that shows all the outcomes. And we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3. And we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20. The length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. The question asks us to find the bearing of A from B. That means we're at B and we're looking at the bearing of A. So bearings always start from north and go clockwise, so we're looking for this angle here. Now there's a few ways of doing this, a few different ways of doing it. The way I'm going to do it is I'm going to find this angle here, and the angle that we're given, the 35 degrees, and this angle are interior angles or co-interior or allied angles, because if we look, they make a beautiful C shape when they're connected, like so. So to work out this angle, what we can do is we can do 180, take away 35, and that would give us 145 degrees. And so this will be 145 degrees. And the method we use for that is that they are interior angles. And then to find the angle we're looking for, we can just do 360, take away the 145, which will give us, 215 degrees. And the reason for that is that they are angles at a point, point add up to 360 degrees. So my answer will be 215. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So we're asked to find the value of n where both sequences have the same term. So I'm going to start off by equaling both nth terms to each other, and then we can find the value of n which gives the same term. So I draw my lines down, and I'm going to start off by getting rid of the n's from both sides. So we look to see which is the smaller amount. So we've got 12n and we've got 6n, so the smaller amount is the 6n. So we're going to take away 6n both sides, and so that would be 6n plus 19, and we've got rid of the 6n, so it's just 79. Next thing we're going to do is get rid of the 19, so take away 19 both sides, and so we've got 6n equals 79, take away 19, which is 60, and finally we just go divide the 6, and so that would be n equals 10. So the value of n is 10. Now we can just test this, because if you do 6 times 10, which is 60, 60 plus 79, which will be 139. And then if we do the same for the top one, 12 times 10, which is 120, plus 19, which is 139. So they both have the same term when n is 10. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78, and we must write down the reason. So corresponding angles, and corresponding angles are equal. Now here we've got an equation, and we want to solve it. So we get our lines in. We'll go first of all. Add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines. And we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180 angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising. Because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10. And that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30 times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So we're told that y is proportional directly to x. So what I'm going to do is just replace that proportionality sign for an equals, and I'm going to times the right hand side by k to be able to do that. Okay, we're told that x is 4 when y is 9.6, so we're going to put in 9.6 for y, I'm going to put in 4 for x to be able to find out what k is. And k is a constant, which means it will always stay the same. So once we find it, we only need to find it once, and we found it forevermore. So that's going to be 2.4. And I'm just going to rewrite this equation here, but we know what k is now. We know it's 2.4. And I'm going to find out what y is when x is 5. So y equals 2.4 times 5, which will equal 12. So we know that y is 12. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15, so w therefore equals 4. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B and then draw an arc from B, and it doesn't matter what the distance is as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the 2 lines join with where the 2 arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. There's a 3 on the outside of the bracket, or cube on the outside of the bracket, and cube means times it by itself 3 times. So we're going to times this by itself 3 times. Now we know the rules of indices say when you times 2 numbers with the same base, you add the powers. So it's going to be 13 plus 13 plus 13, so it's going to be 7 to the power of 39. Now you might notice that actually there's a quicker way of doing this. All we need to do is times the powers, which will also equal 7 to the power of 39. So let's just write out this sequence. So first thing we're going to do is work out what the sequence is going up in, and we can see here that we're adding 15 each time in our sequence, and whatever the sequence is going up in is what goes before n, so it's going to be 15n. Now 15n would give us the 15 times table, and this isn't the 15 times table. So to work out what the offset is, we go and find our 0th term. So instead of adding 15, when we go backwards, we're going to take away 15. And so that would be 10. And so our answer is going to be 15n, and we're going to add that 10 on. So we're asked to rotate the triangle A 90 degrees clockwise and the centre of rotation at 0, 0. So we're going to first of all just show where the centre of rotation is, which is at our origin. And what you do is you get tracing paper, trace out the triangle, and rest your pen or pencil at 0, 0. So I'm just going to draw it out. So just copy it out. And what you do is you'd push your pen into 0, 0. And unfortunately I can't do that. But when you rotate it 90 degrees clockwise, the shape will end up here. And so we just got to line this up perfectly. A little bit less rotation maybe. There we go. And then what you do is you'd lift your tracing paper and just draw in the shape underneath. And it says to label in the triangle as B. To find the smallest possible width, I'm just going to do a quick number line. And all I'm going to do is put 12.2 on our number line and figure out what the next number down will be. Well, if it's the nearest tenth, the next number down would be 12.1. That's the next number down it could have rounded to. And I'm just going to cut this number line in half and find out where our halfway point is. Well, the halfway point would be 12.15, and that's actually the minimum it could have been before it would have rounded to 12.1. I'm just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile, rainbow, and I'll put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So our answer is 35x plus 20. We can rewrite this question as 2 over 3 divided by 20 over 1. So whenever you have an integer, it's just the same as that integer over 1. Now the rule is that we're going to keep, flip, and change. So we're going to keep the first fraction as 2/3, change the divide to a times, and flip the second fraction. Then we multiply the tops and multiply the bottoms. We can actually halve top and bottom here, and it does ask us to simplify it if possible. So our answer is 1 over 30. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here, and that would be minus 0.8 and minus and 0.2, and they're also called roots. So the distance initially travelled is going to be 14 kilometers for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometers travelled. So in total there has been 28 kilometers travelled. When something is cubed, you times it by itself 3 times. So we're going to do the same here. So we've got 5x to the power of minus 6 times 5x to the power of minus 6 times 5x to the power of 6. We're going to put the 5's together. So 5 times 5 times 5. And the x to the power of minus 6's together. Five times 5 times 5 is 125. Now when you times powers with the same base, which we have here because they're all x to the power of minus 6, you add the powers together. So minus 6 plus minus 6 plus minus 6, which is going to be minus 18. Something else we could have done is we could have done 5 to the power of the 3 here, 125, and then done minus 6 times the 3, which would have given us minus 18. So to find the gradient, we need the formula or the equation in the form y equals mx plus c, and the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we're told the length of this rectangle is u, and the width is u plus 2. Doesn't matter which way around we do it. And we're told the area is 80. So we can actually write an equation from this. So u times u plus 2, so that's the length times the width, is equal to the area, which is 80. So let's expand this. And what we're going to do is we're going to put everything to the same side. So all I'm going to do here is subtract 80 from both sides. And so we've got u squared plus 2u minus 80 equals 0. Now we're going to be using quadratics, so we're going to factorise this, and so we need two numbers that add together to make 2 and times together to make minus 80. So I'm going to put my brackets out. So we're going to have u at the start of the brackets, and let's have a think. So it's going to be 8 and 10, and one of them will be positive, one of them will be negative. Well, to add them together to make 2, the 10 will have to be positive, and then the 8 would have to be negative, and then minus 8 times 10 is minus 80. Okay, last thing is we get each of our equations equal to, sorry, each of our brackets equal to 0, so we can solve them. Let's just do this in normal colour. So u minus 8 equals 0, and let's solve that. And so we're going to add 8 both sides, and we've got u equals 8. And we're going to do the same for this right hand bracket, so u plus 10 equals 0. Get our lines in and take away 10 both sides, so u equals minus 10. Now it might get confusing because it says find the value of u, but a length needs to be positive, so this minus 10 is not the correct answer. Our correct answer will be 8. And we can actually check this, because if I fill in the value of 8, so we can have 8 at the top here, and 8 plus 2, which is 10. 8 times 10 is 80. So we know that we've got the right answer. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that. So we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we're going to be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SAW, Ka, Toa. Now we've crossed out the H, so we're not going to be interested in the SAW or the Ka. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labeling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. We're going to start off by just writing the decimal in the standard form, which is 4.3. And we're going to look at the power. Now, if the power is positive, it means the standard form number is a really big number. If it's negative, it means it's a very small number. And here it's negative, so we know it's a small number. Now we're going to do the amount of jumps that it shows in the power. So it says a 5 there, so we're going to do 5 jumps. And because it's a small number, we're going to go to the left to make it a small number. So we're going to go 1, 2, 3, 4, 5 jumps. The new decimal point is going to be here. All the jumps that we made, we're going to fill in with zeros. And because it's decimal, we're going to start it off with a 0. So our new number is, or our ordinary number is 0.00043. Now it's important to realise that we shouldn't really think about it as jumping the decimal point. We're actually shifting the number. But it's all relative, and it's a lot quicker just to move that decimal point. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. Just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21, and then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So the first thing we need to do is factorise the quadratic, and so we put down 2 sets of brackets, and an x will be at the start, and so we're thinking about 2 numbers that times together to make 44 and add together to make that minus 15 there. So the 2 numbers will be minus 11 and minus 4. So minus and a minus is a plus when we times them. 11 times 4 is 44. And then when we add them together, minus 11 plus minus 4 is minus 15. And all we need to do now is get each of the brackets equal to 0 and solve it. Get our lines in, add both sides, add 11 to both sides. And we get x equals 11 as one of the solutions. And then we do exactly the same thing to the other bracket, get it equal to 0. Get our lines in, add 4 both sides, and we've got x equals 4, so our other solution is 4. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution, so x is 2 and y is minus 4. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.